Hello guys, in this video we are going to discuss the solution of the problem swap and maximize. So let us look at the problem statement. The problem statement says given an array ARR of positive elements, consider the array as a circular array, meaning the element of the last element is the first element of the array. The task is to find the maximum sum of absolute differences between consecutive elements with shuffling of array elements allowed. That is, shuffle the array elements and make A1 to An such order that the A1 minus A2 plus A2 minus A3 all the way till An minus A1 is maximized. So for instance, if this is the array which is given to us, if we shuffle this array in this way such that the element contains 1, 8, 2, 4, then the sum of absolute difference between the consecutive element will be maximum, and that sum of absolute difference will be 18, and that is what we are returning over here. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So the general idea behind solving this problem is first to understand how do we shuffle the array such that the sum of absolute difference of the consecutive element is maximum. So first we need to understand what is that arrangement which is going to give me the maximum sum of absolute difference of consecutive element. And once we understood that, then we are going to compute the sum. So let us understand these 2 points in order to solve this problem. So let us first understand which arrangement of the array is going to give us the maximum sum. So to understand that, let us take an array. So let us say this is the array which is given to us. Now in order to maximize the sum, we need to maximize the difference of consecutive elements, and the maximum difference can be obtained by subtracting the smallest element from the largest element. So in a sense, what we need to do is we need to arrange this array in such a way that every smallest element is followed by the largest element. So what do I mean by this is the arrangement of array will look something like this: 1, which is the smallest element, then followed by the largest element, and then again the next smallest element, which is 2, followed by the second largest element, which is 4. And in this way, if we arrange the array, we are going to maximize the difference between the consecutive element. So now let us formalize this. So in order to formalize this, let us take an array and let us say this array consists of n elements. So the first thing which we are going to do over here is we are going to sort the array. And the reason why we are sorting the array is because we want to know the consecutive largest element and the consecutive smallest element. Now, since we have sorted the array, the left side of the array will contains all the smallest element and the right side of the array will contain all the largest element, since the array will be sorted in ascending order. Now after sorting, the array will look something like this. So the array ARR will contain element A0, which is the minimum element, followed by A1, second minimum element, and so on. Similarly, an-2 is the second largest element and an-1 is the largest element of the array. Now, as we have discussed, in order to maximize the difference between the consecutive element, the array has to be arranged something like this. So the largest element and then the smallest element, followed by the second largest element and the second smallest element, followed by the third largest element and third smallest element, and so on. So let us restrict the value of n to 6 in order to formulate our logic. So in that case, the sorted element will be something like this. And as we know, the arrangement which is going to give us the maximum sum will be given by largest element followed by smallest element, second largest element followed by second smallest element, third largest element followed by third smallest element. Now with this array, if we want to compute our sum, then the sum will be A5 minus A0 plus A4 minus A0 plus A4 minus A1 plus A3 minus A1 plus A3 minus A2 plus, since the array is circular, so A5 minus A2. Now let us arrange this, and if we arrange this, what we are going to obtain is sum can be given as A5 plus A4 plus A3 minus twice of A0 plus A1 plus A2. And folks, this is what we are going to do in order to achieve to our answer. So what are we going to do? First, we are going to sort the array, and once we have sorted the array, we are going to compute sum using the formula deduced. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to compute maximum sum and an array is given to us. So for this, what we are going to do is we are going to take an answer which is equals to 0, and we are going to set n equals to len of array, and then we are going to iterate on the array. And then the first thing which we are going to do is we are going to sort this array. Once we have sorted the array, then we are going to iterate on the elements of the array, and folks, this will be n by 2. So let's look up in order to understand this. So as you can see over here, the size of the array was 6 and we are just adding 3 elements, that is why n by 2. Similarly, we are subtracting only 3 elements, that is why n by 2. So we are going to iterate half of the array, and then answer will be answer plus twice of what all elements needs to be added, the last elements a5, a4 and a3. So let's use the last element, which is arr n minus 1 minus I, and we need to subtract. So answer equals to answer minus twice of arr I, and towards the end we just have to return answer. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first let us look at the Python implementation. So over here we have answer equals to 0, n equals to length of array, and then we have sorted the array. Then we are iterating on I while I is less than n by 2, and we are adding the last elements or the largest element, and we are subtracting the smallest element, and then we are returning answer. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same, folks. We have sorted the array, answer equals to 0, n equals to size of the array. Then we are iterating while I is less than n by 2, and we are computing the sum and difference. And then we are increasing answer by twice of largest element and subtracting answer by twice of the smallest element. Towards the end we are returning answer. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.